This is day 57 of coding every day until I hit 1K subs. Today was a mix of practical project updates and a deep dive into some pretty interesting LeetCode problems. Let's get into it. To kick things off, I worked on a few of my ongoing projects, mostly focusing on updates and maintenance. First up, I pushed a small update to my local API bridge tool. This project is a Flask server that lets my VS Code extension talk to various web-based large language models by simulating an open AI-compatible API. Today's update was minor, but it's all about keeping the tool stable. It's built to handle things like rate limiting and browser automation, so even small tweaks are important for reliability. Next, I spent some time on another browser extension, this one for enhancing the Google AI Studio interface. I pushed a fix and updated the documentation to reflect the latest changes. The main goal of this extension is to improve the user experience with small but impactful tweaks, like making the copy button more accessible and preserving markdown formatting when you copy a response. And in the spirit of browser extensions, I started a brand new one today. This one is for Google Keep. It's a simple idea. It dynamically changes the browser tab's title to match the title of the note you're currently viewing. It's a small quality of life improvement I've wanted for a while. After the project work, I switched gears to tackle some LeetCode problems. I ended up solving 4 today, ranging from medium to hard. First up was a hard problem. Count the number of arrays with k-matching adjacent elements. Spoiler alert. The goal is to count how many arrays of a certain length n you can create, using numbers from 1 to m, such that there are exactly k pairs of identical adjacent elements. This solution tackles the problem using combinatorics. It first calculates the number of ways to choose k positions for matching elements out of n-1 possible adjacent slots, using a combination formula. Then, it calculates the number of ways to assign the actual values from m choices, considering that non-matching elements have m-1 options. The final result is the product of these two calculations. The approach pre-computes factorials for efficiency, leading to an overall order n time complexity, where n is the array size. Next, a medium problem. Divide array into arrays with max difference. Here we're given an array of numbers and need to divide it into subarrays of size 3. The catch is that within each subarray, the difference between any two elements must not exceed a given value k. This is a greedy approach that hinges on sorting the array first. By sorting, we can process the numbers in chunks of 3. The key optimization is that for each chunk, we only need to check the difference between the first and last elements. If their difference is within the threshold k, we know all elements in that chunk satisfy the condition. This runs in order n log n time, due to the sort, with constant extra space if the sort is in place. The third problem was another medium, maximum Manhattan distance after k changes. We're given a sequence of moves on a grid, and can change at most k of those moves. We need to find the maximum Manhattan distance from the origin we can achieve at any point during the sequence. This solution employs a greedy, single-pass strategy. It iterates through the movement string, keeping a running count of all 4 directions. At each step, it calculates the maximum possible Manhattan distance up to that point by optimally using the available k changes. The changes are allocated to maximize the north-south and east-west distances independently. The overall maximum distance found at any point is the final answer, achieving order n time and order 1 space. And for the final problem of the day, partition arrays such that maximum difference is k. Given an array, we need to partition it into the minimum number of subsequences, where the difference between the max and min value in each subsequence is at most k. The solution uses a greedy algorithm that starts by sorting the input array. This allows for a single pass to build the minimum number of subsequences. It maintains the minimum value of the current subsequence and adds elements to it as long as the difference condition is met. Once an element violates the k difference, a new subsequence is started, and the count is incremented. The time complexity is dominated by the initial sort, making it order n log n, with constant extra space. And that's a wrap for day 57. It was a good mix of practical development and algorithmic problem solving. If you enjoyed the video or learned something new, be sure to hit the like button and subscribe for more. Let me know in the comments if you've ever built a browser extension. And if you want to support the channel, you can do so over at buymeaboba.com. Link is in the description. Thanks for watching, and I'll see you tomorrow.